In this question, a scientist wants to determine what volume of a 7.46 molar solution of aluminium iodide, AlI3, is needed to produce 10.5 moles of potassium iodide, Ki. Okay, let's start by balancing our equation. So I'll just set up a little table to help me do that. We have aluminium, iodine, and potassium. So to start with, in our reactants, we have AlI3. So that's 1 aluminium and 3 iodine. And we have 1 potassium, just K. In the products, we have Ki. That's 1 potassium and 1 iodine. And then we also have 1 Al, that's aluminium. Okay, so to start with, it looks like aluminium and potassium are balanced, but iodine isn't. So let's add a 3 here in our product side to see if that fixes it. So I'm going to recalculate. On the reactants, I still have 1 aluminium and 3 iodines and 1 potassium. In the products, I now have 3 sets of Ki. So I have 3 potassium and 3 iodine, and I still just have 1 aluminium. Okay. So now it looks like aluminium and iodine are balanced, but K, which is potassium, is not. So looking at our equation, I can just add a 3 here in front of the potassium in the reactants, and that is going to now mean that everything is balanced. So I can go ahead and fill in my numbers. Again, remember that even though usually if there's 1 of something in an equation, we don't write 1 in front, we just leave it blank. On this platform, we do need to add a 1. Okay, so there's our balanced equation. Now let's take a look at the question. We're looking for the volume of aluminium iodide solution needed. We're starting with 10.5 moles of Ki, that's potassium iodide. So we're starting with moles of potassium iodide. We're trying to get into, eventually, volume of aluminium iodide. So we need liters of aluminium iodide. So our first step is going to be converting from moles of potassium iodide to moles of aluminium iodide using our equation to find the ratio there. Then we're going to convert from moles of aluminium iodide into liters of aluminium iodide using the molarity, or in other words, the concentration given in the question. So those are going to be my 2 steps. So for my first step, let's go ahead and fill in our dimensional analysis table. We're going from moles of potassium iodide, Ki, so that's on the bottom because it's going to cancel out, into moles of aluminium iodide, that's AlI3, that's on the top because we want to end up with that. And then for our numbers in there, we need to have a look in our equation and find AlI3 here and Ki here. We can see for every 1 mole of AlI3, we have 3 moles of Ki. So that's going to be our ratio there. That's our conversion between moles of potassium iodide, Ki, into moles of aluminium iodide, AlI3. Then our second step is converting between moles of aluminium iodide and liters of aluminium iodide. In the question, we're told we have a 7.46 molar solution of aluminium iodide. And molar means moles per liter. So that's telling us we have 7.46 moles of aluminium iodide, AlI3, per liter of solution. So what that's telling us is that in 1 liter of solution, we have 7.46 moles of AlI3. So that is going to be our conversion factor that we're using in this question for our solution of aluminium iodide. 1 liter has 7.46 moles of AlI3 in it. So let's go ahead and use that now in our table. So we've got moles of aluminium iodide on the bottom because that wants to cancel out. We want to end up with liters of aluminium iodide on the top. And we know that for every 1 liter of aluminium iodide, we have 7.46 moles of aluminium iodide. So that's how we're going to use our molarity as a conversion factor in our dimensional analysis table. Okay, great. Now that's filled out, we can go ahead and multiply everything on the top, multiply everything on the bottom, divide the top by the bottom. And we're going to cancel units that are the same on the top and the bottom. So moles of Ki cancels, moles of Ali3 cancels, and we're left with 10.5 multiplied by 1 liter of Ali3 divided by 3 multiplied by 7.46. So if we go ahead and put that in our calculator, we're going to get out 0.469 liters of Ali3. So let's just check that answer in our answer box here. Awesome. So again, same as any other stoichiometry problem, but this time we're going to be using our molarity as one of our conversion factors. And remember that M, molar unit, means moles per liter. So 7.46 moles in 1 liter. And that's how we get our conversion factor to use there.